we're supposed to express this series as a rational function. So a rational function would be like 1 over 1 minus x. The power series we worked a lot with in this chapter has been from n equals 0. That's important because it's a little bit different there, okay? From n equals 0 to infinity, x to the nth, that can be rewritten as a rational function. That's just 1 over x. This is like your f of x, kind of similar to what they're looking for here. So what we have doesn't exactly match this formula, but we could rewrite it. This is just 1 over x to the second, all to the nth power, because a power on top of a power would multiply. That would get us back our x to the 2n that we had originally. So this is the same as this. And now we're almost ready to put it into the formula, except for that n equals 1 part. Let's see, what can we do? So that's equal to n equals 0 to infinity 1 over x squared to the nth power, but now we need to minus it by 1, because if these two are to be equivalent to each other, n equals 0, if we were to plug that in, that would make 1 for the sequence. So if we're going to start from n equals 0 to infinity, we have to take out that 1, because the series we were given starts at n equals 1 and not at n equals 0. So this is equivalent to this. We have to subtract it by 1 because we're adding in a new term, the n equals 0 term. We've got to take out the n equals 0 term. Okay, now I think we're ready to substitute. Now we can use the sum of a geometric series. So our x is like 1 over x squared. So this is 1 over 1 minus 1 over x squared, subtracted by that 1 on the outside. So in the bottom here, I'm going to get common denominators in this fraction. And if I do that, we have 1 over x squared minus 1 over x squared. And so you could rewrite this off to the side as 1 divided by x squared minus 1 over x squared. You would flip and multiply the second fraction, right? So this is x squared over x squared minus 1, but I need to subtract it by 1, so I'm just going to get common denominators now. If we do that, then x squared minus x squared makes nothing, and then we have nothing minus that negative 1, so that gives us a positive 1 up top. Okay. I think what a lot of students do when they get this one wrong is, maybe they've gotten halfway there. They get this for an answer. It's just losing that n equals 0 piece. The sum of a geometric series starts from n equals 0 to infinity to use this formula, so we had to back it up one step.